This is Geometry, Unit 8. This is Day 13. We're talking about arc length, and this is our second day. Specifically, we're going to talk about radians. So, up to now, we've been measuring angles in a unit called degrees. However, another unit that we could measure in is called radians. So what we're going to do, we're going to look at a circle. We're going to take the radius. We're going to stretch out that distance along the edge of the circle. And when we connect the end point of the arc with the center of the circle, we make an angle. That angle is called 1 radian. So here we're going to use a computer, and we have a circle. So on our circle, we're going to look at the radius. Now the radius, it says over here on the side, is 4.95. If we take our circle and change the size, we can see that up here in the corner, the radius goes with it. Now what we want to do is make an arc along the circle that is the same length as the radius. So here we have an arc. This is arc BC, and you notice over here that its length of the arc is the same as the radius. And if we go changing the size of the circle, the arc and the radius always stay the same. So 1 radian is the angle that is formed when we connect the endpoints of an arc that happens to be the same length as the radius. That is called 1 radian. It is an angle. Now, how many of these radians do you suspect fit around a circle? Before I ask that question, how many diameters do you recall fit around a circle? And that would be 3.14. Pi is the number of diameters that fit around a circle. So if we talk about a radius, which is half the size of a diameter, how many times would it take that to fit around a circle? And here's a calculation that shows that it's 6.28. If I put in more radian around the circle, you can see that there would be 6 sections plus a little bit extra. That little bit extra would be our 0.28. So there are always, regardless of the size of the circle, there are always 6 radians and a little bit extra, 6.28, that fit around the circle. Now if we look at the diameter, there are 3 radians and a little bit less, even less than before. So that comes out to be 3.14, and here's your calculation that would help you determine that. So the number of radians that fit around a semicircle, or half the circle, is 3.14. The number of radians that fit around the entire circle would be 6.28. We can look at the angle grow as we go along the edge. The degree gets larger until we get to the very end. and that's the length of 1 radian. And you may notice that that would be 57.3. It's really like 57.29 to be exact. That's calculated by taking taking 180 and dividing that by pi. You could try that in a calculator. That would be the exact degree of 1 radian. And then that fits around a circle exactly it fits around a circle 6.28 times. Fits around a semicircle 3.14 times. A radian is an angle that connects the endpoints of an arc that is the length that's equal to a radius. So in our own words, we're going to write down how we would define what a radian is. An angle of size 1 radian. What would be in your own words? What would you suspect? Think of a statement that would explain what 1 radian is. What important words do you think need to be used? What sentence could you possibly use? One radian is the angle formed by an arc equal to the radius. So just to review again, a radian is an angle measure. It's called radian measure. It's not a degree, but it's just like it. It's just a different way to measure. It's a radian. But where do you open it? How much do you open that up? You open it up so it connects the endpoints to an arc. And that arc is the same length as the radius. Using a protractor, we could measure how many degrees 1 radian was. Well, we used the computer, and we saw that 1 radian was approximately 57.3. It was really 0.29. You would calculate that by 180 divided by pi. That would be approximately 57.29 degrees. That's the exact value. And it goes on. We've answered several of these other questions. How many radians would fit around the entire circle, a full circle? In the computer, we took the number of radian and we marked it out throughout the whole circle. There were 6 of them with a little bit left over. 6.28. To calculate that, that would really be 2 pi. 2 pi is the exact radian measure around an entire circle. So instead of using the word 360, we would use the word 2 pi. That's the number of radians that fit around a circle, 6.28. That's the number of 57.29 or 57.3 degrees, how many times that fits around a circle. How many times does radians fit in a semicircle? Fit in half the circle? Well, if it's 6.28 for a full circle, half the circle is going to be 3.14. That's going to be the same as pi. Here's a possible definition of 1 radian. 1 radian is the central angle subtended by an arc that is equal in length to the radius of the circle. You can make sense of that. You can make sense of the other one that we put together. Yours may have been similar. Yesterday we talked about the proportion that can be used to find the length of an arc. That was in degrees, so how is that going to differ now since we're using radian? It's going to be similar. We can take our arc length, that's the variable theta, Greek letter theta, that stands for the variable of an angle. By looking at theta, we don't know if that's degrees or we don't know if that's radian. It's just an angle value. Divided by the entire circle. So what would be the entire circle in a radian measure? That was that 6.28, otherwise known as 2 pi. 2 pi was the exact value. When we took the angle value, the angle that we're working with over the entire circle equals the arc length, which they're saying to use the letter S. S for arc length. Yesterday we actually named the arc. Today we're using a letter to represent the arc. Divided by the entire circle. And the entire circle is called 2 pi r. So we could use this proportion in calculating up what the arc length would be. If you're given the radians, you could use that. Now this can be manipulated a little bit. We could cross multiply, get 2 pi r times theta divided by, what you still have here is 2 pi, and that would leave the S, or the arc length, by itself. If we reduce the 2 pi out of there, we're left with the arc length equaling the radius times theta. That is your arc length. That's what makes using radian so much nicer. When we're calculating the arc length, if we know what the radian is, we can use this much easier formula rather than the proportion we had to use in the past. It depends on what unit you're doing your angles in. So how many radians were in a full circle? The radians. How many radians went around an entire circle? 6.28. That's called 2 pi. How many radians were in a semicircle or a half a circle? 3.14. Half a circle is going to be half of the 2 pi, which is just 1 pi. So with those ideas, we can come down and talk about a unit circle. We won't go into great depth now with the unit circle. You'll do that more in Algebra 2, and you'll use it a lot in pre-calc. But here we have a unit circle. If we were talking about degrees, when we measure an angle, we would start right on the x-axis, and then we would open up our angle counterclockwise, and that angle would get larger and larger. In the very beginning, we would call that 0 degrees. When that angle got to come up to the y-axis, what angle is formed with the x-axis and y-axis? 90 degrees. What angle is formed when you come all the way over to this side? Half the circle is being covered. 180 degrees. All the way down towards the bottom, 270. And then, of course, the entire circle for degrees would be 360. Those would be your angles. Those would be your degrees. Now can we do our angles in radian? Well, at the very beginning would be at 0 pi, 0 radians. Let's jump over to the other side of the circle. How many radians does it take to get to the other side? For a semicircle, we talked about 3.14. That's the number pi. So it's called pi radians. To make a full circle, what would be the radians that make a full circle? Instead of saying 360 degrees, that's one unit you could use, but we can use the term 2 pi to represent a different type of unit. Change the units like you might change centimeters and meters, or inches and yards, or different units. Now, what would the radian be if we were going straight up? We call that 90 degrees, which was half of your 180. So half of your semicircle, half of your pi, is going to be pi divided by 2. Pi over 2. What is it going to be when we come down towards the bottom? Well, if this was 1/2 of the circle, this was 2/2 of the circle that got over to pi. So to come down, that would be 3/2 of the circle. 3 pi over 2. 3/2. Pi is your radian measure. And then, of course, 4/2 is reduced down to 2 pi. Now our center of the circle is at 0, 0. If this is truly a unit circle, then the radius of a circle, the radius of the unit circle is going to be a length of 1. So what would the coordinate be here on the x-axis? That would be 1, 0. Your x value, then your y value. X over, y up and down. What is your coordinate up there at pi over 2? 0 for your x's, 1 for your y. Over at pi, -1 for your x's, 0 for your y. 0 for your x's, -1 for your y. In quadrant 1, all the coordinates are going to be positive for the x's and positive for the y's. In quadrant number 2, all your coordinates are going to be negative for the x's and positive for the y. Quadrant 3, what are the coordinates going to be, positives or negatives? Negative to the left and negative going down. Okay, you've already learned this when you learned about your coordinates, x and y. When we plot points, you know that to the right is positive and you know down is negative. So quadrant number 4 is going to be positive because it's to the right, and then negative because it's below the x-axis. So that ends our lesson about radians and the unit circle.